Okay, so what we have here is a collection of graphs made by a guy named Deke Arndt. And I happened to see these yesterday through a friend of mine named Ed Adlerman. And what these graphs are, in blue, and I hope the color shows up on the camera, we have the minimum temperature in Sydney, New South Wales, Australia, every day from 1959 to 1988. January, February, March, April, May, June, July, August, December. Oh, actually, the months might be backwards on this, although it's sort of symmetric, so it doesn't matter. I know there was a correction, and I actually forget which one I put up, but the date is right. So January might be December, but putting that aside because it's symmetric anyway. And then the red is from 1989 to 2018. So these are the minimum temperatures for the day in Sydney, Australia. Blue, 1959 to 1988. Red, 1989 to 2018. So first of all, well, just tell me what you see when you look at this graph. What are the things you see?
Well, the individual graphs kind of look like normal distributions, although the left sides always seem to be a bit longer than the right side. But maybe that's just I can't see the right side because they're overlapping. And also this might be how the temperature works, but the entire graph kind of looks like a normal distribution.
Oh, okay.
The graph of graphs.
That's interesting. Okay, interesting observations.
Probably the reason you can't see the right-hand side is, I think, all of the red from 1989 to 2018 is shifted to the right.
Okay. All right.
And there's definitely an increase between the two graphs. You can definitely see a shift over. It's not a big shift considering the scale, but this definitely is a shift.
Yeah. Okay. So why did I want to talk about probability distributions before I showed you this graph?
Well, I guess you can maybe see if there's an outlier, and maybe that's just because of low probability, and it doesn't mean a whole lot.
Well,
Like the points kind of at the ends of these graphs, or at the far end of these ones.
Okay.
Well, it does look like for maybe sort of the midpoint, you have a higher probability of getting that than at the ends, and it sort of looks like what we saw before in the bead graph. It's just a little unsymmetric.
Okay. Yeah. So the way I would kind of want to interpret this, like let's pick this one that's in the middle, June, and let's see if we can look at the red one. The red one looks like it's fairly symmetric, and that red graph here for June represents the minimum temperature every day in June from 1989 to 2018. So that's 30 years. June has roughly 30 days, exactly 30 days. So that's about 900 data points. And if I select one of those days at random, what do I expect to happen with regard to this red graph here for June? If I just pick one of those days.
You should expect to get sort of at the top that's about 45 degrees.
Okay, so that
near the middle of your distribution.
Yeah.
Okay, why would I expect to be in the middle there?
Well, it seems like you have a higher probability because this graph goes higher at the center.
There are more data points that are in this range, kind of near the middle.
Yeah.
Okay, good. Does it mean I'm always going to get in the middle?
No.
No, you could maybe select a really hot day or a really cold day.
Okay. And how about if we stick in that same area and we look at the blue distribution here, so that minimum temperature in Sydney from 1959 to 1988.
Well,
what can we say there if I pick one of those days at random? What would I expect?
Well, it seems like you have a wider range here. It sort of evens out at the top, so between this, that's around 37 degrees, And that's about 37 to 45 degrees is like top.
Mm-hmm.
Basically, I mean, the peak is around 40, 41 degrees.
Nice.
So, yeah, you'd expect that.
Okay.
So you're like 3 to 4 degrees colder on average when you pick.
Okay, yeah.